Hi friends, this video lecture is about the Laurent series expansion problems. See the question, expand 7z minus 2 by z into z plus 1 into z minus 2 in the region 1 strictly less than mod z plus 1 less than 3. It doesn't mention what type of expansion, is it Taylor or Lorentz, nothing is given. So this is the question, and it's an important question as well in the exam point of view. For part C question, this question carries 12 marks. Now from the region we get some idea. Let us see the reason. Here mod z plus 1, it represents a circle whose center is minus 1, and it is lies between the two circle with the radius 1 and 3. So 1 is outside the smaller circle with the radius 1 and inside the bigger circle with radius 3, but the center is minus 1. So it means that we can expand this in powers of z plus 1. That is the idea, in powers of z plus 1. So let us substitute z plus 1 is equal to u, right? Otherwise z equal to u minus 1. So this is my given function in terms of z. Let's convert this into in terms of u. So 7z minus 2 replace z by u minus 1, we get 7u minus 7 is equal to 7u minus 9. So numerator is over. The denominator, we have z is nothing but u minus 1, correct? Z plus 1 is u. Z minus 2 is nothing but u minus 3. Got it? Because z equal to u minus 1. So u minus 1 minus 1 is, that is minus 2 is u minus 1 minus 2 is minus 3. So u minus 3. So this is the given function in terms of u. But the denominator, there are three linear terms, am I right? U minus 1, u minus 3. So by using the usual method of partial fraction techniques, we get a by u plus b by u minus 1 plus c by u minus 3. So these a, b, c constants values are minus 3, 1 and 2. So finally the equivalent function is minus 3 by u plus 1 by u minus 1 plus 2 by u minus 3. Now once we got this in terms of u, okay, now how to expand with the help of binomial expansion? So already you know the binomial expansions are valid only when the region of validity, if mod z is less than 1. So here we have the region is 1 less than mod z plus 1 less than 3. We consider that z plus 1 as u. So from this we can find out first the region of convergence, like this 1 less than mod u less than 3, because z plus 1 is u. So we divide this into two parts. 1 less than mod u, so it is outside this unit circle and inside this bigger circle with radius 3. So from the first part, mod 1 by u is less than 1. From the second half, mod u by 3 is less than 1. So this is from the outside circle, this is from the inside circle. So this is the region of convergence, mod 1 by u, this is u by 3. Now this is my given function in terms of u. Here we have only two regions of convergence, 1 by u and u by 3. So let us rearrange. First term I don't touch because minus 3 by u only, so it is as it is remains same. In the second, there is a middle term, I can take u outside so that I can generate 1 by u. In the third term, the last term, I can take 3 outside so that I can get this u by 3 term. So from the middle term, where we'll get this term? Yeah, let us see. I think so in the previous step we found that what we found 1 by u minus 1. So from this we can get this u outside, so 1 by 1 minus 1 by u. The third term 2 by u minus 3, take the minus 3 outside, we get is 2 by minus 3. 1 minus u by 3, right? Got it? So now we have 1 by u by 3. Yes, is correct. Now this is looks like the binomial expansion. Minus 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 minus, so everything is positive term. The nth term is 1 by u full power n. Here the nth term is u by 3 full power. Got it? Let us see. Yeah, minus 3 by u, 1 by u, sigma n equal to 0 to infinity. The nth term is 1 by u power n. Here minus 2 by 3, sigma n equal to 0 to infinity. The nth term is u power n by 3 power n. I multiply 3 into the term, so 3 power n plus 1. Here also when you multiply u by here, u power n plus 1 it comes, no problem, right? Now the final answer is in terms of z only. So we replace once again u by z plus 1. So let's replace u by z plus 1, we get minus 3 by z plus 1 plus, and multiply u here, we get u power n plus 1. Now u is equal to z plus 1, so we get this z plus 1 whole power n plus 1. Here z plus 1 whole power n by 3 power n plus 1. So this is the required Lorentz series expansion in terms of z plus 1. Got it? And in this expansion you see that it contains both the positive powers of z plus 1 and the negative powers, isn't it? How many terms are there in the negative powers? Infinite number. So this is known as the principal part. It contains infinite number of terms. This is the regular part. It also contains infinite number of terms. Got it? So this is the perfect example for the Lorentz series expansion. Got it? This type of questions is really in the exam point of view the long answer questions. Let us try one question. So this is the question for you. Expand 1 by, that is z by z minus 1 z minus 3 in 0 less than mod z minus 1 less than 2 in powers of z minus 1, z minus 1. So take z minus 1 is equal to u, proceed, you will get this one. Got it? And from this what we conclude that, I think from the above problems we conclude that the expansion of f of z and powers of z equal to a is means that the expansion of f of z in powers of z minus a. So z minus a, it means that about the point z equal to a. What about z minus 1 means? It is about the point z is equal to 1. Got it? So this is the idea behind this uh, topic about the point. If about the point, then the reason doesn't specifically given in the question. Even though there is no reason at all, from the point we may expand the given f of z in powers of z minus a. Let us see the example number 1. Expand the function f of z is equal to e to the power z by z minus 1 whole square about the point z minus 1. About the point z minus 1, right? So I can choose z equal to 1, that means z minus 1 equal to u. So z equal to u plus 1. No reason given, only the point is given. I use a previous note. What's the note says that f of z about a point is equal to in powers of z minus a. So z equal to 1 means in powers of z minus 1. So I took z minus 1 equal to u. So we get z equal to u plus 1. Now substitute in the given function z equal to u plus 1 and z minus 1 equal to u, we get e by u squared into e power u. Already we know that the expansion of e power u is 1 plus u by 1 factorial plus u squared by 2 factorial plus etc. Multiply 1 by u squared, here we get 1 by u squared, 1 by u, 1 by 2 factorial is 2, and u squared get cancelled. The next term is u cube by 3 factorial, 1 u squared get cancelled, so u by 3 factorial is 6. So from this we get in terms of u, obviously replace u by z minus 1, we get this term. Okay, in this one how many terms are there in the regular part? I think so infinite number. From this it is positive powers of z minus 1, it is going up to infinity, but there are only two terms in the negative powers, that is the principal part. So there are only finite number of terms in the principal part, right? So this is the idea. Got it? And the similar manner, one more problem, expand z by z plus 1 to z plus 2 about the point z equal to minus 2. See that z equal to minus 2 means z plus 2 is the requirement. So you can take z plus 2 is equal to u, right? So no region is specified here. That is the beauty of this question. No region at all given. Only with the help of the point we can expand it. So when I choose the u is equal to z plus 2, the given z becomes in terms of u. Then using the method of partial fraction, we get it is 2 by u minus 1 by u minus 1. So 2 by u plus 1 minus u. We take the minus sign outside, so plus becomes. So this is the second term. Looks like the binomial expansion 1 minus u whole power minus 1. So let us expand with the help of binomial expansion. Then replace u by z plus 2. It gives this is the required expansion. But once again, in this expansion, there are infinite number of positive terms z plus 2, but only one negative power. So it has some finite number of terms in the principal part. Okay, because the reason was not mentioned, but even though it will generate some regular part, some imaginary part, that is some principal part. So this is a required function of f of z. Is a question was about the point z equal to minus 2. So we get in powers of z plus 2. Got it? So some problems based on this type. Please try these questions. Right? First one is the two regions are given. One is the origin 0, another one is the point 1. Second one is about the point. About the point means in powers of z and z minus 1. Third one is also it is in powers of z plus 1 is required. So take u is equal to z plus 1. And fourth one is only it is looks like the normal Taylor series expansion about the point z is equal to 0, right? Lorentz series expansion about the point z equal to 0 between the two regions. But here the degree of the numerator and denominators are same, so better you can apply the long division method before using the method of partial fraction technique. Got it? So this is the entire concept behind the Lorentz series expansion. Okay, so do well, all the best. Thank you for listening this lecture patiently. All the best. Happy virtual learning.